just put it here. Okay. Small victories. How do you guys feel about if I ask you if I give you 2 vectors in 3 dimensions, could you find the cross product? Yes. How do we feel about that? Yeah. Let's try that. Let's do that while this thing is waking up. So of course, the more you've messed with determinants before now, the easier this kind of thing is. But officially, U cross V is I, J, K, U1, U2, U3, V1, V2, V3. And if you mix these up, you'll get the negative of what you want, right? So be careful about the way it's given to you. Put them in that same order when you put them in the matrix. Yes.
But if you get the negative of what you want, isn't it still kind of, it's either pointing that way or that way?
Now, if I ask for U cross V and you switch them, you've given me V cross U. That's the point, yeah.
Gotcha.
It depends on what you got to do next. Sometimes it doesn't matter. If I just say do this and you need to figure out the orthogonal direction or something, or like the vector that's perfect, then I don't care. Yeah. But if I ask you to do this, you better do this. So if I told you that U was -1, 4, 2, and V is 5, 1, 3, go ahead and try that out. So of course the people that said that's difficult, you'll say, I don't know, Jeff. There's a shortcut to that I don't think I showed you guys. Not really a shortcut, to tell you honestly. Yeah, I don't like it that much because at this level we should be able to do the math required for that in our head. If you can't do the math in your head, then you want to do the other shortcut. Let's stand by. Oh, yes, this one. There it is. Okay, so we'll look at that in a minute. So, what math do you have to think in your head to do I?
4, 2, 1, 3.
12 minus 2. Okay. Right, that's the basic idea. The determinant of this is going to be, we always pick I, J, K, because that just makes it a little bit quicker to get there. You don't have to, but I would. And then you just do the determinant of the little 2 by 2 that's not sharing I's row or column. So we went through that before. So the math for this is not that bad. And if you have to do linear algebra after this, you've gotten a little head start, right? So you got 12 minus 2 is 10. And now for the J, I like it. So it's plus minus plus. So whatever you get for J has got to be the opposite sign. So J is going to be -3 minus 10, 13. So it becomes plus 13. Negative, negative. And then for K, -1 minus 20, -21. Cool. Yeah.
Is there a way to write that like as a formula instead of the?
Yeah, sure, of course.
So
It
I
would
find the
be
box confusing.
U2V3 minus V2U3. All right. You with me? This is going to be unsatisfying. That's too bad. You asked for it. And then it'll be minus U1V3. Yeah, exactly. Sorry. Multiplied by I. Minus, well, let me say plus, screw it. Minus, yep, U1V3 minus V1U3. J hat plus U1V2 minus U2V1 K hat. And if any of you are familiar with permutations, possibly, then there might be an easier way to remember that. I always say, screw it, I know how to do determinants. I have to know how to do determinants for other math anyway, so I might as well use this to get there. But that's the direct formula, right? And this is what I was saying earlier. It's got all the little parts that were not used in that earlier foiling that we did, the earlier multiplication we did, right? Dot product is components. Cross product are all the cross products, the pieces that we didn't use. Okay. All right. So is that cool? That's how you find a cross product.
And that represents a vector that is orthogonal to both
I love it.
U and V.
Good. How could you verify that? What's a quick way to check your answer? If this is supposed to be orthogonal to both of these, check the dot product. The dot product of that with either of these better be 0. It's a quick check. I love it. I'm glad you said that. There's a quick check you can do to make sure you get the right answer. So let's see. We got negative 10. So I got U cross V dotted with U would be negative 10. What is that? 52. And then minus 42. Check. That's 0. Yay! You guys with me there? So I just took this and dotted it with that. The cross product's supposed to be orthogonal to both of these. So the dot product better come out to be freaking 0. I like it. Okay, cool. How could you use what we've done so far to find the angle between these two? Not the dot product. I haven't done the dot product out with Newton, have I?
Yes.
How would you use this? Yeah.
Sine.
You could use the sine theta equals
cross product over the
the length of the cross product divided by their magnitudes, right? The U and V magnitude. Because the cross product length is this. The biggest mistake I see with cross products is that somebody thinks that the cross product is that. Well, that's crazy because that would come out to be a number, and a cross product is supposed to be a vector. So it's the length of the cross product that is that thing that looks like a dot product, just with the other trig.
The same with the area of the parallel.
So this would be the area of what? The rectangle, the parallelogram that this creates, right? Any two vectors you draw down kind of automatically determine a parallelogram, even if they lie on top of each other. That's just a very flat parallelogram, area 0. Right? But it determines a parallelogram. This happens to be the area of the triangle, half that. So be careful I ask you for that, which could very well happen.
The length of that cross product is 10 plus 13 minus 21?
Yes. No, sorry. What'd you say? The length?
Uh-huh.
The length of this would be what? How do you figure out the length?
Square root.
Yeah, square root of the squares. Yeah. Cool. All right, good, you good. So this guy, let me show you what would have been on quiz 2. Wow. You guys see that okay? We need some So now that we went over that together, go ahead and try out that part A. Can you find that cross product? Part B then is easy. Thanks, man. Oh, that stupid light. There. That's gonna be too high up there. Okay. Too bad. Maybe you can just do that.
This is about the other question. It would be the angle in terms of degrees or radians.
It depends on what mode you put your calculator in.
Okay.
I mean, the math doesn't care what we choose to describe our angle in terms of. It's when you do want to do math on something, you want to use the radians in general because that's the true length of the curve, right?
Mm-hmm.
But when we're just talking about, the units we want to use for degrees, it's totally up to us. The math doesn't care.
Okay.
Yeah. Cool. So does that look alright? Is that what you guys are getting? I'm hoping I added and everything correctly.
-14.
I got
Yep.
negative.
That's negative.
So when you do the J, it'll be 1 times 2 minus negative 12. So 2 plus 12 is 14, and then it's a minus because it's that plus minus plus, the checkerboard thing, yeah.
So the area of the parallelogram equation is just either side of that equation you wrote up on the board is.
The area of a parallelogram described by U and V
Right.
is officially the length of U cross V,
Okay.
which is, you could also use UV sine theta,
Okay.
if you happen to know the theta, yeah. Is that cool? So the thing that we already know, that's becoming a lot more direct, is there's always more than one way to do a problem. In this class, you start to realize the two ways are very well defined, right? One way you need an angle, the other way you don't need an angle at all. So it's not quite the same thing as an algebra. Well, you could either add here, you could divide this first, whatever. This is more fundamentally different than they both arrive at the same place. But since I had to do the cross product, I would just go ahead and do this first. If I had you first do the angle between u and v, and then I ask you what's the area of the parallelogram, I might then do u, v, sine theta, because I already know the freaking theta. Right? Instead of doing the cross product stuff that I don't need. You guys kind of with me? So be aware I do that a lot. I ask a question that relates to something else I'm going to ask later. Just use the work you already did there. Right? So it kind of helps you figure out which path to take. And I will have conceptual questions on there, or even possibly little proof questions, which normally I get some moans, groans, and cringes on that, but oh well. What do you think about number 2? It's not too evil.
90 degrees.
And why is that? Because the cross product magnitude is directly related to sine. Right? So for the cross product to be maximum, is the same place where dot product is
0.
minimum. Yeah, 0. Cool. What about this guy here? I like number 3.
Wait.
Sorry.
No, go ahead.
0.
No, the vector has to equal 0.
What was answer to number 2?
Oh, 2 was 90 degrees.
90 degrees. What was the reason?
Since the length of the cross product is directly related to the sine of the angle, right? Cool. Same thing I'd ask about what angle would have to be to make the dot product maximum. You know, then you'd say 0, or you can argue for 180. Same idea.
Just looking for a communications book that I left here.
Oh. You got it? Cool.
I think.
No problem, Ben. Okay. So where we leave off here? Is that good?
Mm-hmm.
Yeah.
For 1A, I actually got the opposite, and I'm not sure how.
Did you put 104 and then negative 312, or the other way around?
I put U first.
Okay, good.
Oh wait, no, I did it the way, not like the.
Oh, you did the
square.
formula that I put up there. Okay.
And I got like I got it as like 4I.
Well, in this case, so U2 is 0, and V3 is 2. Minus V2 is 1, and U3 is 4, so minus 4. That's my negative.
Oh,
yeah.
never mind, I wrote it down.
You're okay. Yeah, it's easy when it's like this. It's easy to kind of get lost in there, but okay.
Can one of those be a 0 vector? Or 3?
Actually, it has to be, right? The only way that you can have 2 vectors. What does this say? That says the 2 vectors have to be perpendicular, and this says they can't be perpendicular, they have to be parallel. So the only way 2 vectors can be both perpendicular and parallel is if one of them is a 0 vector. Or you can argue about this mathematically. Right? Look at the math of this.
Cosine theta equals 0, sine has to equal to 1, or negative 1.
Unless one of the magnitudes is 0.
already.
See, that's where it comes into play. And this is the exact correlation with the 0 product property, whatever the hell you want to. This is why you can factor when it's equal to 0 and then set each piece equal to 0. Because when something times something is 0, one of them's got to be 0. This is the vector equivalent. Since there are 2 ways to multiply, both of these must be true for one of them to have to be 0. Right? If just that is true, does one of them have to be 0? No. Of course not. It just means they have to be parallel. And then the same thing over there. They'd have to be orthogonal. They could be whatever, as long as they're orthogonal. Do you guys follow what I'm saying? I mean, that's interesting to notice. We defined 2 ways to multiply vectors. When they both are taken into consideration, a lot of the old properties come back. Right? If they multiply to be 0 both ways that you can multiply, then one of them has to be 0, the 0 vector. Right? Whereas in algebra, how many ways is there to multiply? One way. Right? You multiply. So I just needed, if they multiply to be 0, period, then one of them is 0. Here I got 2 ways, it's got to be both ways. Okay, maybe.
Can you say again
what must be true about at least one of these is that one of them must be 0. At least one of them. Could, of course, be both of them. Because if you want to look at it mathematically, they say one of them says this, the other one says this. And this is really the length of this, but that's what that would be, right? If the u cross v is 0, that means the length of it is 0. So the only way this could be true, these can't be true at the same time, can they? So then the only thing that really determines it is one of those.
What about pi over 4?
Well, of course, at pi over 4, they're not 0. They're equal, but they're not 0.
I was thinking if u cross b is 0, then u dot b is 0, then we can equate them, right? We can.
Okay. But be careful. Be very careful. I was really careful the way I said this. This is the length of the cross product. Do you see what I'm saying? This is the length of the cross product. You cannot equate u cross v to u dot v. Why? U dot v is a scalar. U cross v is a vector. So I understand what you're doing. You're trying to equate these two things, right? Even if you do that, you get theta equals pi over 4 is one place where they could be equal, but it's not really related directly to these. I mean, you're not really using u cross v directly. You're using the length. So that doesn't quite get me to where I need to be. Yeah?
Could they be two vectors in the same direction?
Well, if they're in the same direction, then the dot product won't be 0. Right? Do you see what I'm saying? So when I gave this quiz last semester, I got a lot of people arguing one side, forgetting that the other side was there. So the arguments here kind of don't match up with these. The only possible answer is what's called the trivial solution. One of them is the 0. In this case, the 0 vector. And then finally, I have this one. So go ahead and try that as I kill my camera.
Can you read off those points?
9, 2, negative 5, negative 1, negative 1, 5.
Thank you.
There it is. Yeah.
And you said when we went over, I forget this 11, 4, 11, 5, you said you choose either point, it's arbitrary?
Just like it's exactly the same as algebra when I say what's the equation line between 1, 9 and 2, 7. You pick whichever one you want to be x1, y1. So here there are like two major different answers to this. They're both the same answer, just one starts there and the other one starts there. Cool. If I have an infinite line, does it really matter what point that I start at? No. Yeah.
We did R of T, so
Say again? Yeah, exactly. R of T.
we had to use R.
So there are really four different answers I could take to this question. Holy crap. Yeah, so here's the way I just happened to do it. I picked this direction, I did this one minus that one. You could have done it the other way, which would lead to this being your direction vector or the negative of this being your direction vector. Cool? Doesn't really matter since you got to go the positive and the negative direction anyway. Doesn't matter. I chose this as my initial position, right? It's the vector that points to one of the points. So I got this equation, that plus t times the direction vector. You could have gotten the other point plus t times that position vector, or you could have gotten either one of these points plus t times the negative of this stupid thing.
You just use different ways.
Yeah, because me deciding to do 9, 2, negative 5 minus negative 1, negative 1, 5, that's a choice I had. You could have went the other way, right? Because what's the vector between those 2 points? Well, there's officially a couple. 1 minus 1 or the other way. Both of them are officially the same direction, really, if I'm talking about a line that goes in both positive multiples and negative multiples of that, right? How are we doing so far? I mean, that's...
If you switch the way you did it, would you have to make the other point the initial position?
Doesn't matter. I could use either point plus t times negative 10, negative 3, 10. Cool. Because again, right here, if I make t1, wouldn't I get 9, 2, negative 5? Right? So I can always recover the other dude. And this is nothing magical. This is the same reason why you can select either point to be x1, y1 in good old y minus y1 business. Because the math is going to make it work out. The slope is always going to get you back to the other point. I don't care which point you pick. Okay, cool. The new thing for us is the slope can't be a ratio truly anymore because there's 3 sides to it now. So I got to represent it as a vector, which is still a direction, which is all the slope ever was, is a direction. Okay, cool. So that's that quiz. That's what it would have looked like.
I would want to take that.
Any other questions on that?
No, on that one. When you were showing us the 2 vectors in a 3D cross product, I wrote it down that the angle of the 2 would be the absolute value of the cross product. Now that's not true. It's the parallel area.
The absolute value of the cross product, the magnitude of the cross product would be uv sine theta. So you'd have to do a similar inverse sine thing like we do with the dot product.
Mm.
Okay.
Mm.
That's as much as I have planned. So it's only up to what you guys want to focus on now.
It'll be too much of spheres and circles.
No, I'm not going to focus too much on the spheres. I'm praying to God you guys remember how to do completely the square, so I'm not going to feel it necessary to test you on that in here. All right? Even if you forgot, you should be able to pick it back up pretty quick. That's going to become important, those spheres and the ball and all that kind of business. It's going to become important when we start talking about what's different with multivariable calculus is that our inputs in the functions are no longer on an axis. They are in a plane for 3D. So what I mean by that is, and this is getting a little bit beyond, but just to give us a look at what's coming up. If I have a function like this, what type of inputs does this require? 2-dimensional input, right? It requires points as inputs. So my domain is going to be possibly, I could define my domain to be a circle. I could even define it to be the points inside of a circle, so it doesn't include the outside. My domain could be here. I can only use those points. You guys kind of with me here? That's when the definition, and when I go up to, so do you guys understand how this is a 3-dimensional Why would this be three-dimensional? I'm only drawing my domain here. Is that cool?
Mm-hmm.
Where would W be? So for this point right there, if I plug in, let's just make that up, 4, 3.
Yeah, you will get the W in the.
My W is going to be sitting over it or under it. You guys see that?
Mm-hmm.
So that W axis is going to be this axis.
It's a function of W X.
Yeah, W is a function of X and Y. I love it. So where the next step we would take would be this. Something like that. That exists in 4 dimensions. We can draw the domain. We can define the domain to be this sphere, right? The ball, or the sphere, whichever way you want to say it. We can use all these points there, because now what does this require as an input? A 3-dimensional point. So there's a picture of the domain. What would the function look like? Holy shit. We can't talk about that. Right? Well, I'll show you when we get there ways that we represent this, and you've seen some of these ways already. You already have seen 4-dimensional things. Believe it or not, you have. For example, let me not leave it hanging there. You're like, what the hell is it doing? I can represent them as colors, yeah. Very often you'll see like a big one that the book uses also is you have the heart. It's got 3 physical dimensions, and they use color to represent the electrical conductivity or something through the heart at that point. You guys with me? So we have to use some alternative means of representing whatever the 4th dimension is, because we can't use a physical 4th dimension that we're aware of. Yes?
So once you get past the 3rd dimension, any other additional dimension is just a description rather than a physical space. You said electrical.
Well, you gotta be careful. I don't want to get into the physics, but right now they believe we live in an 11-dimensional universe with truly 11 physical dimensions. But most of the ones that we're going to see in this class are going to involve
3 physical dimensions.
You just blew everyone's mind.
at most 3 physical dimensions, and the other things would be, like I just said, electrical conductivity.
Descriptions, that's right.
Right. So you could describe a physical dimension in space. So that point up there, I could go up there and take the temperature, the density of the air at that position,
Force of gravity.
you know, force of gravity at that position. I could end up with 6 variables, only 3 of them physical dimension variables, and the other 3 I have to figure out how the hell am I going to represent them. You guys kind of with me here? So having 80 dimensions doesn't mean I'm actually in 80-dimensional space truly physically. It just means I've got that many variables that I'm trying to keep track of. Yes. And that's what happens most of the time. You only get physical dimensionality beyond 3 when you're in weird-ass physics, which we're not going to do. Don't worry. We're not going to get into string theory. Okay, so anything else you guys want to focus on?
Are you gonna go or you want to do our practices on
I've got the answer key here, so I can go ahead and give that out. And actually, there's a few at the end I want to do together because I ran out of room. I didn't want to make a 3rd page, so we'll just do those together. Yeah.
That last question with the direction of the point, did you want us to do the X, Y, and Z equations? Remember how you said?
If you wanted to, if I don't say.
Okay.
So I might say, if I say describe the line parametrically, then I want to see, and actually to tell you honestly, the RFT is parametrically already. But if I said describe it using the X, Y, and Z, then you'd have to use X equals X now plus AZ. I'll tell you this, I'm going to have one problem with a bit of isometric graph that you'll have to graph something 3-dimensional.
We have to get
Just one. Like I just said, I'll have on the test a little isometric piece.
Okay.
You just graph it around. It's not going to be anything major. So make sure you guys are able to handle. Yeah. Be a helix that has periodically changes its.
Yeah, that'd be nice.
Sure, I'll do it.
I'll be here for like a couple hours.
I could just do one thing at a time. No, I'll just tell you right now, no.
No spheres.
It would really just be completing a square exercise, and this is not algebra 2. So we should be able to do that if we have to. And that's why I made the point, that's when it's going to become important to know how to do it. When you want to describe a domain, and it's going to have to be a sphere of points, you have to be able to describe it. So you have to be able to put that together. I think the ones I left off, I did 6A, 6B, and then we could do 6C and 6D, and 7. Well, 7, actually, I don't think we made it that far. Right? We didn't get to the length of curves. That's section 11.8. We didn't make it that far, did we? Yeah, so number 7, don't worry. There's not going to be a find the length of question. Because that's section 11.8. Yeah.
Can a vector be parallel to itself?
Yeah. It almost has to be. The vector 1, 2 is parallel to the vector 2, 4. But, this vector is parallel to that vector. But when I say their names, they both have the same name, like 1, 2, and 1, 2. So I kind of lose information about were they really apart to begin with, or are they really right on top of each other. So in a sense, you then have to say a vector is parallel to itself.
So parallel vectors is like a scalar kind of?
Exactly. Anything that's a scalar multiple of another vector is parallel to that vector. Cool. So of course, that leads to a vector being parallel to itself. It's a scalar multiple of 1. Yeah.
It would be perpendicular to itself.
But that would be a little harder to do.
You're okay with us writing it either way with the -8/35
Oh, yeah,
on
sure.
the side?
Sure. If you want to leave that -8/35 times that, that's fine. Just don't leave it -8/16. I'm going to reduce that down.
Can we take a quick break?
Oh, hell yeah. Yeah, this is review day. You can wander in and out. You can leave early if you want to, if you're ready for the test. Certainly everybody's learning. Oh, hell, man, this is college. You can leave early any damn time you want to. If you want to get down to it. You don't have to come to class. Better let me know when you're not coming.
We were supposed to
Yeah, exactly. So that's what we said over email, right? So tomorrow. No, but I have a class that starts at 9:30. So I think we were saying if we come at. Yeah, because they normally have a meeting from 11 to 12 or 12:30. It's not. The meetings on Thursday probably not going to last till 12:30. Do you have a class before? So if it's okay with you, if you want to just hang out, I could be. The meetings on Thursday are really flexible. It kind of depends on how much there is. It's related to a meeting, and it really depends on how much there is to talk about. What's that?
I have to take a look at it.
Take a look and then give it back, because I might scan it and put it up on the internet. So if you could come out and just hang out, if that's okay, just hang out in my office. Because I might get there a lot earlier. Cool.
Is that correct?
So which one is that? Oh, okay.
With the sign, it's a circle by two.
Now, the thing you gotta be careful, it doesn't make a complete circle in a single plane. Because every time t is changing, it's also changing.
Yeah, I understand. I see what you're going. It's going that way, and it's moving. It's moving. Yeah, yeah. So
And the
like
real
this.
problem is, in no direction is it allowed to go beyond a certain amount. You see it because I mean, sine is going to go.
Yeah, I see that because this one is basically zero.
How is it going up?
It's going down.
How is getting this far up the z-axis is what I'm asking. But the thing you got to be careful about is, how is it getting out that far?
Because it's going with the sign. Because z is the sign. Is the sign. So if you drew the z like because this is my z.
Let's see as so for sine.
Yeah.
There it's going to become negative. So it can only go out along the z-axis. It can only go out, and then it's got to come back.
That's what's happening here. I mean, because see, it's coming out, and then it's going
Is that your
back.
y?
That's my y. This is x, and this is the z. So you can see it. It's going this way up. It's going back, and then up, it comes back, it comes up to you, and then it continues like that. See, it's going.
Let's see how come. Oh, I see. But this is this thing. So if I have this here, the largest number that can go here
There's one.
is 1.
Yeah.
You've already gone past 1. On the z-axis, you've already gone beyond it. How can you do that?
Oh yeah, that's the z. Oh yeah. What I'm doing, this is the z. Yeah, I see what you're doing.
In the other direction, like 1 and 2, so it can go out this direction and those 2.
I just see everyone
And you got this as the x. And one little thing you got to be careful because it should be the y and this the x in this case.
Yeah.
And then these two, it can go 2 and 2, 2, and here it can only go 1. So it should be circular and somehow come back and be back here sometimes.
How are you gonna draw it? How do you draw it?
Well, I would realize that I would just make a series of points. Not like that.
Yeah.
I would do it just a series like we had to do before, except now it's going to be more like that.
Oh yeah.
So I would do t, and then my x, y, z.
Yeah.
And actually just make points with it.
Okay.
Do the main ones first, and then see if you have to fill in anything else in the middle. What's happening? So if you take now one good idea, I can't remember exactly what it was.
2
So if you take that out, you know that's going to be a circle radius 2.
And that's what I started. I started with the 2.
But the minute you start moving,
this has to go up.
it has to pull out a little bit. And then think about it. By the time you get to pi over 2, so
I shouldn't have gone. Yeah.
think about the angle you're at. So the minute you starts off, where we are. So it's going to be here for the I. It starts off at maximum, right?
Yeah.
So the minute you start changing the angle, you start pulling up away from it. But the minute you get to, so the minute you get to, so it comes up and then back down. The minute you get to I over 2, it's got to be back to 0. It's going to be back again.
Yeah.
That's not what I'm drawing the world to do without the little specifics here.
I was trying to be
So I know. Yeah. Good, so I took that vector we found there, divided it by something. That's going to give you just the direction of u plus minus 2 and then multiply by the length of u to make these have the same length. Good. Exactly. So if I want w parallel to A with the same length as V, that'll be the length of V. Got to be parallel to A, right? And it's got to have the same, and it has to have this length, so I better divide this length out of the way. So this is length 1, but it's in the direction of A. And then now it's got the same length as v because I multiplied by the length. Okay. Good. Yep. Like I said, you're right.
So it just comes out to the side of.
Let's see.
Oh yeah. Yeah, and how far down the outline is it? Yeah, now that they really need, how far down the outline. So they're not really being specific about, is it truly height? Is it truly this way? No, they mean how far down the outline. So if you're standing up there and you're looking down and you say, how far am I going to land? You're going to measure it in that direction, right? That's what you would do physically. So if I'm like, if I roll something down and it stops, I'd say it stopped. So I'm up here and I'm like, let's roll this thing down and it rolls to here. Well, how far did it go? This far. So you want to measure along that. So isn't that your question you're asking? Is it this distance? No. Is it this distance? No. It's this distance. Yeah.
So if you want to do that,
Good. Exactly.
maybe I found the relationship between this distance and
That's the first.
would they I found a kind of relationship between them.
All right.
But then how to get to the
Well, if you can find can you find the components of how far he's gone? How far has he gone in this direction? How far has he gone in this direction? If you can find those components, you can certainly find the length of that vector. Right? If you can figure out how far he's gone in this direction, how far he's gone in that direction, related to this, you can then find the length of that, right? So if he's gone 20, negative 10, then that's the vector 20, negative 10. You can find the length. And that's what they're asking for.
That's what I mean. We don't have these numbers because we don't have this distance and we don't have this distance for sure. We have a relationship between them. So we said this is x. We have this. We can get this as a function of x or as a number, like multiplied by x. But we don't have the actual.
But at some point, if they're parallel to the surface, so it does have to hit that surface. It should be able to fit there. So I'm not sure what function you're using.
The only thing is, if you do that, it's that it would be a problem. About that. And you'll get 2 points.
It's taken off from here, and its initial position is 0, 8.
I'm getting over it. I missed last time. I was really sick.
And so it takes off. This is an angle of 30. So it takes off. Bam! What's going to change that is, as far as his velocity, this is going to stay the same. Because they're assuming nothing's affecting it besides gravity. This is going to change. 19A, I'm not sure what they're saying.
I have the position right here.
Where's it in? Oh no, good. It's in here. Okay, good.
I got the position vector.
Okay, good.
I got this position vector. How to find the x and y? How to find where the land is more.
So you're gonna have to know. So if it's like this, all I have to do is figure out how long until it's 0 again. So do the same thing, but now you kind of it's at an angle. So how long until I'm back on the same line? There's actually many different ways to do that.
I understood that he's not gonna he's not gonna hit something. He's not gonna hit here. He's gonna hit here.
So be careful. They'd have to be a lot more specific if this suddenly changed. The relationship has, and I don't like the fact that you're right. I don't like the fact they did that. Assume that this goes forever like that.
Because this is easy.
Because otherwise they'd have to tell you.
Yeah.
But you're right. So assume this. Otherwise,
Now this
otherwise it's actually really easy also because then you just say however far that is. But you can't really tell that from the picture. But you have to assume this is forever. So you're right. That's the part that made it difficult. But now it shouldn't be that.
Yeah, now it's separate.
Good.
Thank you.
I have an actual question.
Yeah.
So for 11.7 extra credit, the homework actually is an extra credit. It's just the problem on the test that will be extra credit.
No, the homework's extra credit also.
Oh, okay.
How much is that?